I'm glad to introduce Derek Dreyer for this last session, of PLMW. Derek will give a talk that he's given many times on how to write papers, and it's every time I learn something new, so pay attention.
like a tree with a bunch of different sub branches. So what's the trick for getting flow when you're
So, yeah, so a good example of that. So, let me first say, I still think the principle holds new applies, but it is, yes, this example is very simple. It's a linear flow. Many paragraphs have more of a three-line structure, or you might have, sorry, yes, it works. Okay. I'll just finish it. It's a good question. So, a common example is a kind of list paragraph. So you may have a paragraph where you say, there are a number of reasons why, blah, blah, blah. First, this, second, this, okay, and then, so then clearly there's some other structure there, but it's very clear from the way it's structured, or from the words you're using, like first, second, third, how this relates to the previous thing. But often, yeah, you have to. This is where a course is important. To go into where, I mean, yes, it's more complicated than the way I'm saying it, but still, I would say the beginning of sentences should connect back to the basic principles. It's just that actually making it work may require a little bit. Okay, so I'll continue. Oops, sorry. So that was flow.
It doesn't seem to have a consistent topic, right? So yeah.
It's incoherent.
So you mentioned the 2 points about flow and coherence, and it feels like one is the opposite of the other, because you mentioned for the second one you should put your point first, but the point is someone new in this paragraph. So
another way of, yeah, I understand your question. That's a good question. So another way of thinking about it is that the point that you make is like a higher level point that you're going to be discussing. Right? It might not have right, the points of individual sentences. So each sentence, of course, has something it's trying to convey as well. But those are sort of more detailed points, right? And they're feeding into this larger point that is the overarching point of the paragraph. So they're not really in conflict. It's just they're different levels.
okay, thanks.
Yeah, I have a question about this just-in-time principle. Anecdotally, sometimes I experience when people don't put the background section up front first, I don't understand what they're talking about in the actual content of the paper because I don't have the background. So is this just something that you have to accept that people without the background are not going to understand the beginning of your paper until they get to that point, or?
No, I mean, it depends on the work or the particular subject. What I often do in my papers is I often have a section 2, and we'll be getting to this in a little bit, which is presenting the key ideas of the paper. And often in that section, just in order to explain the key ideas, you have to give some of the background. You have to review something from previous work which you're building on. That's a perfectly fine place to put it because you're going to use it right there. Right? It's different from saying, here's all my notation about things, like you don't even know what they are. And then they get used in looking at where they fit. So just, if you're going to present that technical stuff, present it right when you need it. It doesn't mean you shouldn't present it. Just you need more time.
There's also a question about the just-in-time. So one thing I've been told by my advisors is that sometimes people read papers in a non-linear fashion. So let's say I've introduced some background just in time in one bit of the paper, but actually I keep using it then in other sections, and then a reader might be confused because they will try to find this maybe in the background, but actually I've introduced it just in time in one place where technically in the linear flow of the paper that was the right place to introduce it, but not if somebody reads it in a different way. And then another question also building on top of that, this thing that you mentioned in the overview section, I also struggle with this a lot I think there's like this really short paper by Leslie Lamport, which is like state the problem before introducing your solution. And there I struggle with this, like, what if I need specific vocabulary to express the problem? And then sometimes I feel like if you don't want to devolve into this whole background section, you have to kind of put some forward references in the sense of like, okay, I won't exactly explain what this is. I will mention it now, but yeah, it's kind of a constant tension that keeps up.
This always happens with 2 parts. But okay, I can give you the general answer. The general answer I would say is, I remember the first part of your question. So actually, for the first part of your question,
get into all the technical details.
Yeah, they want to get
is making some important contributions. And I'm not saying it shouldn't get accepted, but as a practical matter, if you want to get your paper accepted, it's better if it's interesting. Okay, it makes the paper more accessible or more memorable, especially to the non-expert reviewers, but often to the expert reviewers as well. There has to be some interesting takeaways, some insights that make them remember the paper. One answer which no one gave, which I'm happy no one gave, but I often hear is, how is your work challenging, right? So you want to impress the reviewers that this was really hard and you struggled. And often that translates into, writing out in detail all the things you did that didn't work or something like this, and to impress them that this was really hard to do. Reviewers don't care, okay? Whether it's challenging or not is really not relevant unless it affects these other questions. Like maybe the things that made it challenging are also why your solution is very interesting. Then that's fine, but focus on what's interesting, not trying to impress the reviewers. Yeah?
Is the notion of interesting here, I think some people like to feel that some results are also surprising.
Yeah, it doesn't have to be surprising necessarily. Sorry, yeah. The question was, whether you have to show that something is surprising. I don't think it has to necessarily be surprising, but it has to be, by the way, it doesn't have to do this thing. This is just something that helps make the paper better, right? It makes it more memorable if there's something, some takeaway, right? Some interesting insights. But they don't necessarily have to be dramatically surprising. All right. So, how do you implement these overarching principles? There are a number of ways of doing this, and I don't want you to think this is the only way to structure a paper. Okay, I have structured my own papers sometimes in somewhat different ways. There's many ways to do this. Okay, but this is a structure that works, and I use it a lot, and not just me, a lot of people use this a lot. So I think it's worth understanding, and it may be a good starting point for you. So the idea is basically there's 5 key things. The abstract. Okay, abstract's very short. That's just like 1 or 2 paragraphs. The introduction to the paper. The key ideas section, and we'll get back to this later, but this is related to this interesting bit. The technical meat, where you explain all your technical details, and related work section. So first of all, before I say anything more, can you guess which of these 5 I'm not going to talk about today? Technical meat, why? Yeah, that's one reason. It varies. It really varies a lot. It's very hard to give general advice about the technical meat. That's true, but there's another reason. Well, I mean, of course it's important, right? But why is it the least impactful?
Because the least people read it.
Yeah, 5 people read it, okay. That may be an over-approximation, okay? I mean, so there's the 3 on that. Well, actually, yeah, I hate to break it to you, the program committee members don't always read the technical meat. They're supposed to, but, it's often difficult. So, yeah, very few people are going to read that technical meat unless they really need to build on your work. So, you want to make the other parts, which are going to be more accessible to more readers, really good. Of course, the technical meat should also be really good. I'm not saying it shouldn't, but focus your first efforts on the other sections. So let's start with the abstract and intro. And I'm going to mostly talk about the abstract, actually, because the intro follows basically the same principles as the abstract. So the approach that I use is something called the CGI model. And this stands for context gap innovation. Okay, so what are these 3 things? These are sort of the 3 stages of your abstract or your intro. The context sets the stage and motivates the general topic of your paper. Okay, so this is not the specific problem you're solving. It's sort of like it's bringing the reader into the space, the research space that you're working in. Right, starting at a point where you think that they probably can understand. Right, a very general opening. Then there's the gap. The gap is where you explain your specific problem and why existing work does not adequately solve it. Okay, you should be very concrete about explaining what exactly that problem is. And then there's the innovation. So this is where you state what you've done that's new, and you explain how it helps fill the gap that you just stated. Okay? So why does this address the problem? Well, first of all, this is top-down. Right? You're starting at a high level of things that most people would find accessible, and you're getting more detailed into the work you're actually doing. Okay? That's number one. And as for the tell them what they want to know, you're addressing importance. Why is the work important? With this context and gap, right? That's sort of saying, like, this is a generally important problem that people work on, and here's a specific problem within that space that is unsolved. So that explains the importance. And then novelty, right? And the gap and innovation go to novelty because the gap clearly explains what is the thing that hasn't been done before, and the innovation explains how you're helping to fill that gap and by doing something new. Okay? So this structure is sort of naturally addresses those two overarching principles. So let me give you an example by just giving you a little abstract for this talk. So, and you'll see the context gap innovation as I do it. Learning to write well is an essential part of becoming a successful researcher. Unfortunately, many researchers find it very hard to write well because they do not know how to view their text from the perspective of the reader. In this talk, we will present a simple set of principles for good writing based on an understanding of how readers process information. Unlike such platitudes as be clear or omit needless words, our principles are constructive. One can easily check whether a piece of text satisfies them, and if it does not, the principles suggest concrete ways to improve it. Okay? So this is a very typical structure that I use for abstracts and for intros. Obviously, for intros, it's not one sentence for each of these things, or two sentences. It's going to be several paragraphs. Okay, but this gives you the general idea. Hopefully, there's not another file around the building. Okay. Now, I have to confess something. So this is usually where I stop talking about CGI, but I just wanted to add another slide here because I realized as I'm giving this talk here that you might think after this talk, oh, well, I should look, Derek, I see he has a paper at POPL, and maybe I should look at his paper and see how he does this and see whether he practices what he preaches. And unfortunately, I don't always practice what I preach. So I looked at the paper that I have at POPL this year, and it does not actually follow the CGI model. So let's take a look at it. What does it do? So this is a paper we have presented on Thursday by my postdoc, Ina Lynn George. And it's a really cool paper. I'm not going to talk about the details here. But the key thing to notice is this does not follow CGI at all. Okay? So it starts out by saying, we present DRF-CAML, an extension of OCaml's type system that guarantees data race freedom for multi-threaded OCaml programs while retaining backward compatibility with existing sequential OCaml code. And then it goes on from there in a very non-flowy kind of way. Right? So it's like really not following any principles I'm talking about today. We build this, we introduce this, we show this, we formalize this. This is another way of doing an abstract. This does not follow the CGI model, but it's an example of how there are different ways of doing things. Okay? So, of course, one thing you can learn from this is that I did not write this abstract. Okay? One of my co-authors did. I checked. I was like, did I write the abstract? No, I didn't. So it's not generally my style to do this, but that's a question of style. But there are reasons why you might do an abstract this way. Can anyone imagine what those reasons might be? Yeah.
If you have limited words to express your thoughts, you don't want to give the background.
Certainly, if you have a space issue, but that was not an issue here. Anything else? Yeah.
9 co-authors.
Yeah, but I mean, okay. In this case, I remember reading the abstract someone else wrote. I was like, yeah, it's fine. Any other reasons? So, oh yeah, go ahead. You're opening with the most important, not only the most important part, this first sentence is a very concise summary of the entire paper. Okay, so sometimes you can do that. Most of the time you can't, because most of the time it's very hard to summarize in one sentence the entire paper. Okay, and even here, like you have to care about OCaml to care about this, but probably if you don't care about OCaml, maybe this paper is not so interesting to you. Maybe not, but so by doing it this way, you're sort of saying this is what we're doing, and if you're interested in this, you're immediately interested in by the first sentence. Okay, so it conveys a certain what I would call confidence. It's like this should be interesting to you. So like, and if you get that from the first sentence, then you're great. And if the content is clear, I mean, in this case, the flow is not such an issue because this is really like a bunch of bullet points. It's not really a paragraph that you would read in a paper. Like you would never write a paragraph like this in the body of the paper because that would be hard to read. This is more like an executive summary, like if you had bullet points on a slide. That can work fine. So this is just an example of how there's different ways to do things, but that can work very well. All right, so. What, 3 minutes? Okay, fine. I'll be quick. All right, 1 minute on this slide. So, good. About introductions, I'm not going to say very much, except they're basically, I almost always, for introductions, follow the CGI model. There is an alternative approach that Simon Peyton-Jones recommends in his talk, which is to eliminate the context entirely and get straight to the, start with a concrete example, like, here's some Haskell code, and then, starts talking about it. That can work very well. Again, if it sort of, it makes it clear that if you're interested in Haskell, this paper may be for you, and if you're not, probably not. Okay, so that can work. It depends on what audience you're trying to target. But I often find it assumes too much knowledge of the reader, too much context, so it doesn't usually work for me. All right, let me get to key ideas. I'll do 1 minute on key ideas and one on related work. So the key ideas is, there's a lot to say about key ideas. The main thing I suggest is have a key ideas section. So this comes after the intro, and the whole point of this section is you want to get across some key takeaway messages from your work, okay? And I do this basically by viewing it as you're at the whiteboard. You're trying to explain your work by drawing pictures on the board, explaining things with concrete, motivating examples. You're not trying to explain the general solution. You're not trying to explain the technical details. You're just trying to give across high-level intuition about what's interesting about about your work or how the thing is working. Right, and as I said, I'm not going to go into here, but basically, this forces you to have a takeaway, have something interesting that you can explain, right? And often, if you don't have a key ideas section, it's sort of a signal that maybe there's, it's a more technical paper and it's harder to explain something interesting. Finally, related work. So this is a super important section. So I just want, this is my last slide. There's two things I want to say about it. This section, often people put this in one of two places. They put it either at the beginning of the paper, maybe in the introduction or right after the introduction, or they put it at the end of the paper. I strongly recommend putting this at the end of the paper. This is somewhat controversial. Some people, really like the other way. The reason I say to put it at the end of the paper is that you can't really properly compare it to related work until you've explained what you've done. And so at the beginning of the paper, it's too early. The reader doesn't know what you did yet, so how can you really give a precise technical comparison? This doesn't mean that you don't compare at all with related work in the beginning of the paper, because of course, in the introduction, when you're explaining the gap, or the thing that's not solved by prior work, you have to say something about the related work, because that's how you're establishing the gap. But that's usually very short. You're like briefly saying what the previous work doesn't do. That's totally different from a related work section where you go into detail about a lot of technical stuff. The second point is you want to give real comparisons. So the worst thing you can do in a related work section is just sort of, you feel like, you need to cite all these people. So you just write a paragraph about each paper that by a PC member that you think you need to cite, and you say nothing interesting. All right, that's terrible. Then whenever someone does that to me as a reviewer, I'm like, ugh. So I'd rather they didn't cite me than to cite me in a boring way, right? I want the reader, the writer to give real comparisons that explain in detail how their work fills the gap in a way that the related work doesn't. And with that, I'm basically done. So just to summarize, flow with old to new, coherence with one paragraph, 1 point. We talked about name your baby, just in time, and short subjects. Abstract and intro should follow the CGI model most of the time, although there are some other ways of doing things. Have a key ideas section if you can. It really helps to scaffold the presentation and put the related work section at the end. Thank you, and hope you get something out of this.
Thanks, Derek. We have time. We had a lot of questions in the middle, but we also had a gap intermission, so maybe we have time for one more question while we make sure the panel is being set up. Yes.
Is key ideas a real section, or is it just at the end of the introduction?
Usually, it can be both, but usually for me it's a real section. So often in the introduction you do also have some part where you're explaining what's interesting about the work, and often that's that could be like the very short version of the key ideas section. But typically I have a multi-page key ideas section, like often the intro from my paper. If we have like a 25-page paper for POPL, then the intro might be 4 pages or 4 or 5 pages, and the key ideas might be 5 or 6 pages. I mean, it could be, it varies, but yeah, it's usually a real section where you actually give concrete example. You work through some concrete examples that take space. Last question.
Is the key ideas, I think some people call this the overview section?
Yeah, there's various names for it, yeah.
Okay.
I mean, the thing is, it's not quite the same as there's a section often people call an overview that's here's the architecture of my system. That is also useful, and sometimes that's the right section to put in section 2 because it gives a sort of, it follows this top-down thing. Like here's the big picture, and then you go into more details. But it's not quite the same as key ideas where you bring out these sort of key technical takeaways.
Awesome.
All right, thank you.
Let's thank Derek again. And